Hello everyone. Are we live yet? I hope so. Hello Dutch. Hello 404. Yes. Yes. Nice. Okay. I was working. Hey Rota! So early? What? Yeah. My throat is still sore and my eye is damaged. I don't know if you could see it. I poked a stick inside of my eye and had to go to the doctor, but it's getting better now. Hey Johnny. Hey Sonic. So I was working. Hey Kenny. How many fingers you hold up? I would say 3. Kenny, hello. Georgia. Wait, traveling back home to Georgia from Tennessee. I don't know where Tennessee and Georgia is. Tennessee, isn't it like southeast? Where the whiskey is from? Let me check. Maps. Tennessee, let's see. Ah, yeah, Georgia. Oh, yeah, okay. So it's neighboring. I didn't know that Georgia is here, just above Florida. All right. So you're on vacation right now? Oh well. So I worked on the bus system, and I uploaded even a short on bitluni shorts and TikTok and whatnot, showing the issues that I had with. You were? Okay. Hey Peter. Greetings to Boulder. What is oopsie? Okay, where is the bus? Here. So I'm trying to. I had problems with the bus sending data back to my MCUs since last time, and dogs. What did I dogs? Oh. Oh no. Oh no. All right. There was. Wait a second. What did I show? Fucking doxing. Oh no. Yeah, nice. All right. I might need to fix that. Yeah, you can if you're living in the neighborhood, give me a call and then we can meet up for a beer. Anyway, now I'm sweating. Now I need to open the window and take off my vest. Yeah. Hey Adam, by the way. All right, so I had issues like we have on our cluster. Wait, let me turn on the camera here. We have more or less like the host MCU and the client MCUs, and what I'm trying to figure out. Let me show that. Okay. So the issue was that the host is clocking, like these are the individual clock lines here on that one that's improvised. It's clocking back the data, but the little MCUs weren't able to provide the data in time. So what I did since last time, I have refactored everything. No, yeah, I did actually, but there is like an intermediate step. I think it's on my GitHub where I used external GPIO interrupts to, where is the bus here? Interrupts like this here to basically trigger, set the data and so on, and that worked out. But there is a slight issue with that still, or a thing that I wanted to change was that we have let me show that on that one here, so you can see the individual card here. Okay, so this is like the cluster card, and we have like, hey Christian, thank you for the sub. And we have like two 8-bit registers here, of which I used one for address. A was used for address and B for the data. So the MCUs that are not targeted could ignore all that communication. Now with the interrupt, there is the issue that I would trigger, like interrupt all the MCUs that are connected to the same clock, I would say. So this is like in that case, I think IO1, yeah, this is an individual clock and so on. So it's not a problem if there is only one card like here, because we have an individual clock for each MCU. But on this cluster it would be a problem because 10 MCUs are sharing the same clock signal, and I would interrupt all of them even though I'm just talking to one MCU all the time, and they would like check the ID always, and then basically ignore if it's not meant for them. What I also introduced is buffers. So an outgoing buffer and an incoming buffer. Where's the desk? Wait, here. And now I reworked everything because somehow, okay, so I implemented like a simple ring buffer here of size 32, and I made like the bus, it has like in and out buffer. And then I thought, oh well, we have yeah, I almost lost an eye since we saw each other. So I'm only seeing half of you. Actually, my oh, I can show you the eye how it looked like. I can explain what happened. I was doing gardening and apparently I'm not very talented at it. It's really gross. So trigger warning. Do you see that area with the goo? There is like this goo on top of my eye. Yeah, there it's injured. I was really lucky. I show you what happened. It looks gross, does it? Okay, so I draw a stick figure. Here we go. All right, so this is my lawn, and here is my lawnmower, and here I am pushing the lawnmower. And here was like bigger grass and sticks and whatnot. And yeah, and here's the stuff coming out. Yeah, and then next pane here. There was like in this area here. This area. There was something like a bigger stick, and here's the lawnmower. Bigger stuff on the floor, on the floor, and I wanted to pick that up. So I went there. Yeah, I went there, and I wanted. So I saw that here. What is this? This is not good for my lawnmower here. So I went and bent over to pick that up, that thing. And what happened next? Wait. What happened next is like here is the stuff on the floor, some stone or whatever. And I'm standing here and bending over to pick this up. So I want to pick up that stuff. So I want this here to pick that up, and here is a close-up what happened next. Like that. That's what happened. Yeah, it hurt. Yeah. I was just hoping that it's not bleeding. I mean, apparently, as you can see, it was bleeding internally. Oh, thank you, Fu. Yeah, it was, I was really fast. I was moving fast. I'm really surprised how durable eyes are. I got a stick in my eye. So, I was really surprised that I didn't lose my eye, because it was like, I was moving like that. It was like Wait, maybe I can show this. I was moving. Yeah, okay, I can thumbnail. This was my eye, and I was moving like that. This is what happened. Yeah, and first of I thought like I checked first and I saw instantly like some bleeding inside of the eye, but it wasn't like oozing out or whatever. And then it seemed to be alright. I mean, it felt like there is like debris inside, and I checked, there was nothing. And then I went to bed in the evening, and next day I woke up, it was completely glued shut. Yeah, I can see. I don't have like it's let me finish the story. So basically, I woke up. It was like glued shut with what is this oozing stuff that you have like on open wounds. Like it was like glued shut, and it got a little bit worse the next day. But it was on Sunday, and Monday I thought like the doctor is closed, but I checked like Google Maps. I checked it wrong or whatever. And it got even worse in the evening. So this was like this picture actually. This picture was from Monday. It happened on Saturday, and this was on Monday, and there was like this gun coming out of the eye here. So I don't know if you can see the reflection, the specular reflection on that. It's like snot or whatever. Yeah, gross. Huh? And I thought, oh, it's not getting better. So I went to the doctors, and I was surprised. I got like quickly an appointment, or I just went without an appointment, called beforehand, talked to an AI, jumped on my car and went to the city. And they called me back while I was driving there. And within 2 hours, the doctor checked and gave me some medicine with antibiotics, so it doesn't get inflamed or whatever. It's or infected. And he said, yeah, it's obviously injured, but it will be all right. So I don't know. It looks a little bit gross. So when I'm filming, I will take like a pirate eye patch or something. But I think it will be all right, and I think it's better today already. Like it's still red, but it doesn't itch anymore. It still hurts. Like the eye is a little bit swollen and hurts, but not as much as yesterday or the day before. Oh, you have hay fever? All right, yeah. I'm sorry. Your eye is having a cold? Yeah, I was having a cold. I was sick for 2 weeks almost. And then I infected Tony and took care of Tony all the time. And she's... my 3D vision is alright. I would say I lost a little bit of sharpness on my right eye, but I hope that has to do with like that it might be inflamed a little bit. But the lens, or I was lucky that I hit the side of my eye, not the center. So the lens and anything there isn't like injured. It's only like the white area. So, but still they did a side test, and left eye was like way better. Like the not injured eye was like way sharper than the right one. So I don't see the difference. I mean, it's a little bit like maybe because of the gunk in my eye and the ooze, a little bit soft. Yeah, but other than that, I think it will be alright. You hit a small toe today. It's blue now. Oh no, it's probably broken. I had my toe broken several times in my life and never did anything about it. At some point, even like I think like even the toenail on my small toe is like completely like wonky because it's bleeding so often and it hurts so much. I know that can hurt as well. Obliterated, yes. Have you hit your toe once like that the nail split in half and was bleeding in the center? Yeah, I'm somehow like, I don't know, sloppy, or I don't know how that could happen with the eye. I need to be like wearing glasses when doing gardening in future. But it was so stupid, I just bent over and poked the eye and almost lost my sight. Yes, I did. I actually finished mowing. It took me like another half an hour maybe. And even the mower at the end fell apart because I lost the screw and the handle went off and I was just pushing by one stick. It was like, I just wanted to be finished with that word. Safety squint. Actually, when that happened, I was like in mid squint. I mean, it still like went in between the lids, but safety squint probably prevented it from the stick penetrating. Penetrating all the layers. It got only like through one or two layers of my eye. Anyways, grossness done. Good practice for the lasers. Ah, no. Anyways, let's talk about the bus system. Nah, forget that. Safety, yes, safety squinting practice. Brain impaled, yeah. I would I mean, you know how much that cost me? Like that injury, going to a doctor, getting medicine. I paid €5 for the medicine. I mean, I pay like what's the rate that I'm paying? Around 500 or something for my health insurance a month. Alright, that's a lot, but I can't imagine, like, I'm sorry if it gets a little bit political, but I can't imagine like what I would do if I was living in the US. I wouldn't go to the doctor. I would just try to sit it out even longer. It's horror stories out of USA. Yeah, I mean, it was like, I don't know, maybe I hear from time to time like stories I see from people that you have to be like, even if you have a health insurance and you go like to the ER or something, or to the hospital, then the hospital needs to be in your network, then the doctor inside of the hospital needs to be in your network, otherwise you pay it yourself privately. Tax and tariff, no. And then on top of that, you have like a deductible of several thousand. So before even the insurance starts paying, you will like pay out of your pocket 2,000 or something. Is this a regular thing happening in the US, or is this like not like, if you work you have like insurance or something? They would send you to a specialized doctor where you pay like 10,000. What? Crazy. I would rather lose my eye than paying 10,000. I don't have 10,000. uploads. You missed the story time. Anyways, some personal experience from US would be nice if someone can tell crazy stories. Or other countries. I mean, how is it in Colombia? Foo. I heard about glowing clothing holders instead of dentists. What? I mean, it's not all nice and dandy. And my experience yesterday is actually to burn out teeth. Oh! Oh, you mean like coat hangers, metal coat hanger, glowing metal coat hanger to burn out like cavities? I don't pay anything when I got injuries like that. Nice. Oh, okay. That's gross story. Yeah. So usually I must also admit German's healthcare system is also on the verge of collapsing. Because I don't know. It's like it seems like most of the doctors will give only like the appointments to privately insured people. So we have like a two class system. Vet bills, yeah. Actually, there is like I think you can have insurance as well for your pets, but they're quite expensive. I know that my sister paid like thousands and thousands for her cat that were sick all the time. Yeah, so usually if you want to get an appointment at a specialist or something, you wait at least 3 months for that appointment. Not if you're privately insured or you have like the Unfallversicherung, which is basically insurance for accidents. How is it called? What's the name, the English name for Unfallversicherung? And if it's during work time, then you have like this extra insurance. You're insured by, I don't know, Knappschaft or it's so you have like more or less a 2-class system. If you're happy to have like an extra insurance or whatever, you probably get Genossenschaft. Yeah, you get extra. Oh yeah. Oh no. Yeah. But I somehow cheat the system always because I ignore everything. They say you have like to go to your regular doctor to get redirected to the specialist or whatever, or you need to like use of your insurance like the hotline to find the next free doctor appointment or whatever there is. There are also apps. But what I do, I never go to the doctor unless it's an emergency. So I just call in and say, oh yeah, it's an emergency. Can I come in? And then I just expect to be like in the waiting room for 2 hours or something. What doesn't work in Germany is going to the emergency room. In the emergency room, you can expect to wait like, especially on weekends, like 5 hours to get your ibuprofen. Yeah, to meet up the doctor who will look at you. If you need stitches, you will get. I waited with a friend 5 hours for him to get stitches with his open hand. So ER is no good. I went once with I had a injured my ankle during sports, and I went to the ER and I was standing in line with my not broken, it was like ripped muscles and so on. in my ankle. I was standing in line for half an hour before I was even like really in the ER, and was like my name was asked or whatever. So I couldn't stand anymore. I went home, went to bed, and went to the special doctor just the next day. I had like this extra insurance because it was like sports with whatnot. So, but usually, the best trick is don't care about appointments. Go to the specialist, tell it's an emergency, and yeah, usually you have like an emergency. Leidensdruck is the keyword as well. And you just sit down in the waiting room, and within 2 hours, everything is covered. You don't need to wait like for ages. Probably they can charge more from the insurance or whatever if you say it's an emergency, or I don't know. But usually I don't wait longer than, like, I don't have appointments and I don't wait for long, except for dentists, but I go regularly. German is hard. Had to wait 13 hours for them to adjust my dislocated knee. Oh, dislocated knee. Ow. Typical ER experience. At this point, you know what I would try? I would try to like lock my foot somewhere like in the door in the ER, and then pulling my leg, demonstrating to them that I need to be taken care of right now. Rezniecensu Serguju. Romania, 45% of salary taken by state. Don't use medical services that often. Thus every 4 months I pay what you pay for a visit without any of the benefits. Oh yeah. I mean, we pay a lot, but there is like also very many old people that need like a lot of care in Germany, that I'm considered still like young and healthy, so I'm not going that often to the doctors. I wasn't sick for 2 years now. I got a shot and dentist, but I have also extra insurance for my teeth. Yeah, so not much going on. What? Foo! Thank you for the 4,000 Colombian pesos. You can basically weld the whole sentence into one. That is how Rindfleisch-Etikettierungsüberwachungsaufgabenübertragungsgesetz is made. Alright, so back to the bus. We're talking about buses. Story times are cool. I had a swollen foot and did not know what caused it. I was afraid I could have been gangrene. What is gangrene? What is that? What is gangrene? Let me draw while you explain. Ah, gangrene. Ah, well, this is an illness? I'm not familiar with that. I didn't unlock this. Wait. A death of body tissue due to lack of blood flow or serious bacterial infection, gangrene. Yeah, alright, yeah, that's to worry about, yeah. Alright, peeps. Here we go. So these are the usable IOs. This is not usable. This is A1. This is basically LED. We used that before, but I'm not using that anymore since. So I would say this is then we have this is C, this is D, 0 dot dot 7, 0 dot dot 7, the American 7 without the stroke here. Okay, here we go. So what I did so far, MS Paint, yeah. This is A2. So what we did so far is we took this as a clock. That was the simple mode. And whenever the clock went high, there was like C was address. So we have like oops. So this is address or ID. Let's say ID. It's shorter. ID of the MCU, and this is data. Data. And now what I encountered is the problem that usually we have like this hardware layer here, and then we needed to interpret what old parallel memory. Yeah, we needed to check this for what is happening there. I can show you an example here in the top. So this was like the instruction, and we had something like LED or ping or whatever. This was like the first byte. So we needed to interpret that. So we needed to take a look at this with this I here. Or let's say this is the instruction. And then depending on the instruction, maximal, yeah, 255. Since we can start at any point, we need like to keep this ID here. So if we trigger all the other MCUs, they need to see, oh, it's still not meant for me. And then we had like maybe more data, or D1 and so on. Or if it was expecting return information like polling data, then it would do the following. It would pass over to the client, and the client would acknowledge with, oh yeah, I understand that I need to do something, return data. It would send its own ID. So this is how it worked. Own ID and then a response. So let's say return value 0, and so on. So this is how it worked so far. And there are some issues with that, because look at that. We are wasting a lot of bits and bytes. I need to close Steam here. Okay. A lot of lines just to send the ID over and over again, because some MCU might be busy and misses that information. Yeah. here misses that information and starts at this point, and then this could be interpreted wrong and so on. So what I change now is I go back to what we had in the old cluster. That's a clock and a command line. Let me check that here. Bloop. So I use this one as a command. So this will be now cmd. CMD. That indicates the start of a packet, and then I switched lanes. This will be data, but on start of a packet, this is the ID where the host polls or whatever, the ID, and then this here, this is D7 reset pin. Let's ignore that because that causes us trouble debugging or programming it. I need always to unplug it and whatnot and do a power cycle. And this one here is SWI interface. We can also ignore that. What I introduced here is a new CLK, new clock that's taking over. Oh yeah, I'm also inverting everything. You need to invert this here because we are I decided to invert everything because we are in open drain mode. So every signal is now inverted as well. I'm trying to change everything up here. So we have the clock now, which will deal as a new clock after this. This is also served by the host. Maybe we should do some color coding. Okay. Command to set MCU in debug mode. Now we can still reuse the lines, but I don't need them anymore because what we had before was wasting a lot of lines, and I can just keep them free. We can reuse them for something else. What I do now is I take this here, these 2 bits is the packet type. Let me put this in type. Actually, I don't use this for anything else. We could use it for something else. So this can stay for as long as the packet is long. If you see like some issues with that, okay. But type could be, let me draw it here. What is the type? Type, broadcast here, okay. reset, receive. I don't not I don't use reset, but basically receive, transmit, and broadcast. These are the important ones. Reset is just for completion. If the host MCU for some reason restarted or whatever, it can just reset everything and clear all the buffers from all the client MCUs. But we can say it's either RX, TX, or broadcast, which is a special mode because then we don't use all the lines. So this is basically also set by the host. Then I added a new line, which is, what do we have? Ready. I will make it short, RDY. Ready, which is high all the time, and once the MCU that's targeted, or let me use that, TCP UDP on that. Probably I'm too lazy to read, so you can tell me what the difference is. Okay, so we have the ready signal whenever the client MCU received that packet and interpreted it, it will set ready, I'm ready for the next clock cycle. And then the main MCU, so if you can see that here, the main MCU, like the host, will see, oh, we have a ready, then it will set the clock high, and the MCU will then release ready, because for the next packet it needs to be like acknowledging again data ready or whatever is doing there. So it will look like that. It will always trigger the host MCU whenever it's ready to receive data, transmit data, whatever. So this is client here. Ready is always client. Since the host is dealing with the clock or providing the clock, this is only like a host client bus. We could do, I don't know, we could probably try to use it for peer-to-peer, but I don't know how. I don't want like to stress it today. Okay, then we have another signal which is full. That's just indicating, was this that color? I don't know. That's just indicating whenever our buffer is full. So we said the buffer is the input buffer is full. It's just convenience signal. Oh, how do I? Here. Oh no, the ready needs to be set after the full. Okay, like that. Yeah, that's all software. And then we have the last signal is end of transmission. That's what I came up with, what I thought it will be useful. Huh? Okay, here. EOT. So this will basically work like that. and everything will be released here on the clock. Because at the end we need all our lines to be free. Okay, so the host just checks if you're sending like a stream or something. It can send, the host can send receive data, so Rx or whatever, and then the client expects, like every new clock cycle here, expects a new data, which will be here. Oops. D0. Then we have oh wait. No, actually it's done already. The buffer is full after this. But usually you can set the data, but in this case it already said after this byte that it's full. So this is nonsense. It won't send anything after the buffer is full, so we don't lose data on the way or whatever. What is going on? Why can't I? So, and the host sees, all right, buffer is full, end of transmission. Anyways, a lot of stuff going on there, and this is the new implementation of that. Okay, this is old school. The advantage of that is here, we trigger all the MCUs. Where's my mouse? Here. We trigger the MCUs. We trigger the MCUs only once, and after that, they don't. So we identify the MCU that's meant, and this MCU enables the interrupt for the clock signal, the actual data clock. The other ones will ignore it. So we have silence for the others, while the MCU that's meant, and maybe broadcast, all the MCUs are meant. On broadcast also the ready signal. I don't know. The host doesn't respond immediately after the ready. It has to wait or something. So more than one will receive that. But that helps, and also it indicates the start of a packet. So if we lose data or whatever, always a packet start is always in the beginning, and it's not depending on the data or on the type of packet that we are sending, that we would expect something like here result. It would like fetch result, or ping would fetch a response or whatever. We can always like send to a specific ID, send basic data, and how that data looks like is up to us. We can always, like, the host has to pull data back in some way. Rotary, yeah, you should use also I/O interrupts for that. Yeah, but interrupts. Interestingly, there are no examples no working examples for the 003 MCUs. I found a solution, or there was an example that wasn't working for me. The issue was that the examples that I found online were only predefining, like I have the bus interrupt here. Wait, we're predefining a standard name for the interrupt vector, and we're expecting that the compiler or linker sets the vector correctly. But that didn't work in this SDK or whatever. So I found this solution to set this virtual table, what it is, I don't know what that works now, or I tested it with the version before that, but this, hey Coolpad, this version isn't tested yet. I did an abstraction layer, so I don't know if that will work. This is basically the whole logic is within bus. That's where it's implemented with a bunch of virtual methods, and this is called when we have here handle request, when we have ETF. Yeah, why isn't, maybe you know why it's not working. So what do I have to do? Because I would need like to either write into the memory where the IQ table is set, but it never worked for me. No, why would you need an optical level shifter? Is it 5 volts? There are 5 volt tolerant pins. Usually they are tolerant. If you have like an 1k ohms resistor or something, that shouldn't harm. You have a body diode for that. If it's level. But optically, usually. Roman check CC. Oh, wait. How do you turn that on? Real-time close capture. Wait. How do I turn that on? Oh. Do you know the setting, how I can do that? Because I don't see anything in the studio here. Look at that. Maybe here. Overlay for brakes. Yeah, probably that's. There is not much I can set here, you know. This is all I can see. I could change the settings. Wait. Sorry, I don't know how, really. Doesn't ISR definition need an attribute with the RQ number? Yeah, so I show you how it's initialized. Here. This is like the trigger is GPIO-A and line number 2 and falling edge. This is setting up the external trigger. Then the clock to the alternate function IO is needed, and then it just, all the examples I saw just enable external interrupt 7 0RQN, and there was like, it was only like defining the method, nothing else. I don't know how to set the ISR without like the compiler pulling the definition or something. But that worked, so everything else was ending in a deadlock of the MCU. Maybe it worked, and then the return the return type of the interrupt wasn't right because of the attribute, but the attribute is interrupt. I'm sorry, Roman. I don't know how to fix that. Maybe there's like a third-party plugin or something that does that real time. Yeah, anyways, yeah, I have to use for the external interrupts, they are sharing the interrupt here. Are we there yet? Hey, Johnny. Almost. So I'm using A2 for navigate stream settings tab, scroll down until you find close cap toggle settings on. Okay. Huh? Find go live and click, then navigate stream settings tab. I'm in the settings, but scroll down until you find closed captions. No, there's nothing there. It's probably, I have to set this up before the stream starts, otherwise it might not work. I'm sorry. I will check for next time, so we have like the default settings with turned on captions. Anyways, I implemented the client side, and now I'm asking myself, well, yeah, but I will check. I will check. I hope that I will remember. Maybe, you know what? Let's check that right now. Channel level settings. Ah! Closed captions here. Yeah, okay. This is before creating the stream. Yeah. Okay. I will turn it on for the next time, sorry. Hot air gun for heat shrink. Tubing get hot enough for surface mount soldering. I don't know, I never owned one. I'm using hot air gun for surface mount soldering for the heat shrink. That is hot enough. Okay, so there is like, this is the abstract bus design. Default startup code just assumes certain fixed names for ISRs. Yeah. I used that, but it didn't work. I don't know why. I really used the correct name. It didn't work. So that's why I don't care anymore. That's why I don't care if the linker doesn't find it. Oh, I know why. I know why. You know what the issue was? I show you what the issue was. That was the issue. I need to extern C, otherwise it okay, yeah. It's in the main. No, I'm using C++, that's why. I need to extern C that function. There we go, yeah. Anyways, I use that now. Or is it slower? Basil, what do you know? Do you know, is it slower using it like that or not? Wait. Reason? Yeah, I like object-oriented programming. In that case, bus is object-oriented because I have like this abstract design of the bus that is transferable to other devices, and I just need to like implement initializing the right I/O and setting the interrupts and setting the right flags and so on. Yeah, it's not performant, but yeah, I was lost in the 1,000 lines of C code. That's why I'm using that. I mean, it's still like stupid because this class would need to be static, but then I can't use virtual functions. So it's a compromise anyways. But yeah, and I need to use bus and that to dispatch it from the... I mean, I could do this as a static method, but then I still need to dispatch the bus. Compile node red for an ESP32. Maybe, I don't know. Alright, so I think when I was done before, it compiled. The issue that I have right now is this is only the client side, the client bus. So what I would need is transfer or put a class in between. Class client bus public bus yeah, let's take it, but send data, send request. That's bullshit. Virtual init IO, why does it do that here? Doesn't need. Let's remove that crap. Okay, client bus, because handle data clock high, handle data clock low, all that stuff, handle requests, all that is client implementation. All right. bus. State idle. We don't even need a state here. Init IO. I will leave it. Request type. Process received data. Okay. I guess we can reuse everything here. Handle. Hey, I'm a Boyd. And this one will be client bus. All right. I can now copy the implementation, or I split it in here. Client, or do I call it client bus? Or hardware abstraction layer, how do I call it? Instance. Okay, let's move everything from here over there, because that's the implementation. Whoop. Client, this is the implementation. GPIOD, okay, we need to include something else. Include CH. Okay. Client bus. Does it compile? Oh yeah. It's to fix that. Okay, the only thing that's missing here is the host bus. And the host, we can put it here as well. Class host bus, public bus, everything is implemented. And handle request, handled. So what we will do here is not handle request. We will do the following. We will implement new methods that will be basically void send Send packet. No. Okay. ID. And then that's data const and size. Okay. Ooh, it did something. That can be ignored because we are of control of the whole bus. The output buffer, I'm not even sure if we need it in that case. The only thing that could happen is like the buffer is full and then we need to handle stuff. I would consider like enjoyer size t. Yeah, but what's the probably, I don't know. Probably it's more enjoyer to use a byte here because if we construct a packet, we will always use like 1 byte to describe the size. There's not much. I'm not. We could maybe template it at some point, but I don't want to stress it right now. Let's leave it like that. Out buffer. I don't even think we need this. State transmit. Oh yeah, size t. Nothing to send. Yeah, that won't happen. State. Oh, set type, request transmit. Okay, so this is the first thing that works. Set data ID. That was also wiped correctly. And now we need to get set comment. Set, where is it? It's not there. Okay. CMD. And we can do that because we don't need to implement that. We don't need to implement that for the client. We also don't need get comment. Nobody messes with that for the time being. Okay, so host bus is basically set CMD, and then we will just wait for while ready. Why not get ready? Delay micro. No, we don't need that. We could delay here microseconds or something, but we can just wait. Wait and do nothing. to do timeout. Oh! So crazy. So crazy. Okay, reset CMD is correct. So let's take a look at our cheat sheet. We are here. We set the type. We set the ID. Clock is not necessary here. But actually we will set the clock. Set clock before we set comment. Set set clock. We don't have set clock yet because that's all handled by on the client side by the interrupts. Oops. But there is one instance here. I think set red get where we can actually use that. No, we don't stress it. The implementation here would be get clock. Okay, set clock, reset command, we set clock. Oh, we don't reset clock. We will now read stuff first because reset clock triggers the MCU to do something. Yeah, to delete the ready signal here. When we reset that happens. So we need to get ready first. Oh wait, get ready was here. But we need also to get full. Because we need to know if the buffer on the other side is full. If get full means basically buffer is full, reset clock, return. Okay. I take that suggestion for now. Okay, let me to do here. Buffer is full, reset clock, and that's basically happening in. Let me get full, and then we do full here. And move the reset clock before that. Okay. State transmit, that's alright. Let's do that. We can do this, implement this in interrupts maybe at some point to optimize, but for now let's keep it there. For size, out buffer, write data, nah, don't need that. Set AOT enable transmit. Set ready. Nope. Nothing like that. Oh no! Oh yeah, wait. Huh? That's it! Yeah, this is correct. Wait. Let's check. Set clock, reset clock. Oh, there's full missing. Oh, wait. We are already ready here. So we need to do this first and then wait for the readiness. So set data, reset clock. Otherwise, okay, in that case, it's either full or something. Reset clock, we need to wait for reset ready. So while get ready, we need to wait for it to acknowledge the clock change. So we are currently here, ready is done. Now we set again the data, set clock, then we wait for it, and before we reset clock we do the same as above. Unfortunately it's just copy paste. We don't need the state transmit, that's not needed here. While get ready, wait, where is it? Ah! Okay, what we can do is, let's do this bool. Isn't full, just don't pull ready low. Buffer full. Okay, so this is on before we send the first oh yeah, it is ready. What we maybe need to rename ready to acknowledge ACK, because in that case we also, oh yeah, that's also interesting, we need to end the transmission here. We will probably see like a common occurrence here, like set blah and then check the states or something. If it's full, we also need to end the transmission. So usually we would be doing the following: reset the clock, or do we end the transmission before? No, we set 1 clock more. Wait, release the clock. No, peeps. We need to do it like here. We need to end the transmission before we do the full thing. So in that case, because the other side is reacting on the rising clock, we need to set AOT to acknowledge that the buffer is full and end the transmission, and then we need to reset the clock and basically also release everything else. So we need to clear data, reset data. Reset data here. Reset data. We need to clear all the lines because it's open drain. Reset data, reset clock, reset type, reset, where's type? It's also not implemented. Set type here. I think I will also, to prevent issues with that here, I will do an implementation just on the, not in the hardware abstraction layer, like I mean on the client and host level. Okay, get clock. Okay, reset type. Maybe we should do in the same order. Reset type. Everything that the host says, that's A2. Data, type, clock, and end of transmission. End of transmission needs an acknowledgement as well. You know what? I need to change ready to ACK. Damn it. renaming that. Oh no. Okay, I keep ready for now. Set command. Yeah, we need to reset command here. Oh, we can do that here. We can also reset everything. We don't need that. Set, reset type. Type is never read after that point. We could actually reuse the 2 bits. Star Trek codes. Which ones? Reset clock. And then we would need... Oh, wait. We don't need to wait for the end of transmission. We could reset end of transmission. It's not reused anywhere. Since we are the host, reset EOT, we can just do it in the beginning. And any odd state would be covered by that. But we can do this here. Reset CLK. And then we will do the waiting thing while at ready, and then basically reset EOT here. Return false. In that case, buffer is full. Sends a packet if return true if okay, we need to expect that that the buffer is always big enough on the client side for a whole packet. Oh, it's so odd. Reset CLK, reset type, reset CLK. Okay, this is like the first request to client. There is never a timeout, which is terrible. Usually if there we might need a timeout here. Timeout. 1 second. All right. Ah, oh, where am I? Huh? Huh? Send packet? What? Why does it copy everything? Timeout. Yeah. No. I don't want you to copy everything. Ah. Okay. Delay microseconds 100. Come on, int. Let's do that. Probably we don't need like 100 milliseconds would be enough. If it doesn't respond, then it doesn't respond. Delay microseconds and then wait. I will basically time out. Yeah. Send messages from end to end as JSON. I mean, the buffer is always like a ring buffer, and the maximum we are only limited by the maximum size. I would say if we need more, we can allocate more. Like if we know we're sending a big chunk of data, or we chop it up in small chunks. But this is like the layer above. I would keep like everything separated. The bus, it doesn't need to know what the contents of the data in the end are. And this is like the software layer, where the protocol layer, where we tell it, all right, the first byte is the size of the packet, and then origin, whatever, and size of the packet or chunk number, and we can send it in chunks if it needs to like do whatever with that. Is this correct? Reset type, reset clock, reset comment, reset data is missing. Reset data is missing. That looks like it needs. It needs some sort of clearing function. Okay, the timeout of 100. Microseconds. Feels like it's too much. But this delay also doesn't work properly. Is there a debug? I need include debug. Because the delay is defined there. I'm getting hungry. Why I'm getting hungry? Okay. Wait a second, I forgot something. State transmit. Here set. Interesting. Transmit. End of transmit can also be sent during set during client sending data. Set ready. If get EOT, yeah, set disable transmit, reset EOT, since we are changing it, reset data, since we sending data. What else did we? Reset ready. I missed that part here. This will be very hard to debug, I believe. I hope I will be able to debug that some way or form. Disable and reset, what was it, ready, that was missing. Oh, reset full, set full also. Okay, resetting signals on an open drain bus is necessary. All right. Back to our stuff. So if we are sending a ping, it will time out at some point if there is no ID like that. Then in that case it just doesn't react. Then if it reacts, reset command, reset type, then it checks if it's full. So this will be this case. Why does it? Oh yeah, if we receive data, then we can check for EOT. EOT if there is no data. Set end of transmission. Reset data, reset clock. Get ready. While ready, reset EOT. And that's all. So if we set EOT, we waiting for ready to be released, and that's happening here. If get EOT or if get EOT, reset ready. Reset ready. Okay. So this is the case of buffer full. It's hard. So now we mastered the header, reset clock, and wait until it's not ready anymore. We are then in the transmit state. Then we set the data, set the clock. Oh, we also need to end the transmission here. So get full. We need to end the transmission just like this. This is same here. It's copy paste code. Set. Oh, we need to check if it's the last byte. Oh, it got it right. Otherwise, we are successful anyways. This is the case. And if it got it right. Set EOT. Yeah, we don't need to reset it if it wasn't set. It's performance. Set EOT. Okay, it ends here. Get ready. So it might be EOT get ready. Then we're done. And what we do here at the end, the transmission is so awkward. Where's this here? Okay, reset data, reset clock. No, clock is reset already. No, set clock. Reset clock. This is missing here. Reset clock. All right. We are missing stuff. Okay, clock is reset already. Type is reset, comment is reset. Did we miss anything? Oh yeah, EOT. We had EOT here. Reset, set EOT, and clock is reset. EOT, full, ready, there's nothing else left. Okay, we are able to transmit stuff here. Now, there will be one issue here with client bus. Reset command, no. Virtual bool get CLK. Okay, this is not right. It is right. It's D0. Oh wait, I hope I didn't mess that up. Data get type equals 0 equals 0 equals 0. Okay, not that there is something inverted. Get CLK. Oh, is it void? And the implementation. Boss. Okay, so this is this abstraction. We are missing stuff. Set reset command, set reset clocks, reset. Okay. Now I will put this in the client bus. Which one? How do I copy that? Generate copy pilot summary. Oh wait. Can copy that part. Apparently. Wait, what? Okay, good night, 4-4. I hope we are able to do some tests today. Set command void set cmd virtual void reset cmd. Reset type. Oh, actually reset data is needed here. We need that. That needs to be implemented here. So reset data will be think this is now. Okay, we have two problems. Yeah. Here we can do. Nein! Here. There was only a warning, I believe. All right. Now we can copy the whole bus and or should we add more new file? Wait. That's client bus. Maybe I will move bus hal h, which include I include okay. So this will be the abstraction, and this will be the new client bus. So we have actually, we should also rename the, since these are actual, oh damn. Wait, which ones do we need? Okay. Let me rename those. Since these are classes, under Windows, it's hard to rename stuff. Oops. Especially if you want that camel case. Or we call it client bus, whatever. Not hardware abstraction, it was very... Okay, here we go. Client bus, and then we need to change that down there. Compile. to V3. Okay. Oh! Hey, MSSJSSM. Errors. Oh, 45 errors, okay. Implicit type. Oh. Was this the error? No more problems. Okay. All right. What I need is to copy that into the host here. So yes, the 80. I'm rewriting it to work like that. It's sophisticated. You need to rewind the stream to the place where I describe how that works. And now I think I got the abstraction. No, what's missing is the host side abstraction layer, a hardware abstraction layer, or the host side hardware layer, and the receive method for the host. And then we just need to the first test with Blinky or something. Ah, yeah. You Spanish people take your time in the evenings. I wish I had dinner. I'm really hungry right now. I don't know. I'm too sloppy. Okay, where do I find the real? Yeah, ocular gore. That was gross. Yeah. Open timeline. Open. Huh? Reveal in File Explorer. This is what I want. Okay, so I'm copying that part. I'm removing actually I'm stupid. Okay, we have new bus here, and there is new file, and there is host bus h, and there is new file, and that will be host bus ch32v208.h. Okay, so what I will do is now I will get that part, host bus, remove it, put it here. Pragma once, include bus, include debug, include standard in pragma. All right, this is that part. Then I need client bus. I will just copy that and put it here because it has a lot of stuff. Host bus, and what do I include here? That's the right one. We don't have interrupts yet. Eight. Init IO. Okay, this is where we need to initialize all the IOs. So this is old, and now we need to remove that host eight bus, and then we will see what's missing. Oh, 208. These are not implemented yet. Yeah, I will get that. Get CLK. Move it. Set CLK, reset CLK, get CLK, this will be here. Wait, what is it? Set CLK. Void set. You know what? I let it do it one by one. Set comment, reset comment, yes, I take that. This will be probably wrong, but I got that covered. Set comment, no. Dude, CLK. Wait, reset. Okay, get CLK. These are. Now I just need to reset type. Okay. Brutal. Okay, indentation, and now I need to just, the only thing that's missing here, that's not needed. And now we need to do the hardware. Okay, first of all, we throw away the interrupts. We don't need that. We don't use that. We don't need that. Host bus, wait, GPIO. So which one? MCU pins. Bus pins. Oh. I think that's all. See, let's check. We have all here. So first of all, we have the IOs, which are, yikes. Oh, D and A's. Boss Bank. No, this is wrong. Wrong on this one. G&D Bank. A D A D O. Shoot. Let me find. Oh no, I deleted the original. Oh, set MCU. Wait. Button. Any GPIO. Oh no. I shouldn't have deleted the old stuff. Now I have to figure out everything. Okay, that was A and B. This is 840. Let me check that. 840D. 840D. Okay, so this is G&D Bank. I will just take that part. Oh wait, can it be const? No, I don't think. Damn it. That's not G&D Bank, that's MCU Bank. Okay, I'll just take it like it is. I lost my fondue. The fondue plate is somewhere here. But I might get a bread to get rejuvenated. MCU pin. Let me get... Oops. So we need bank A and D. Not sure if we need C yet. Whoops. Here. Open drain now. GPA or boss pins. Not working, but I'm still using it here. Push pull. Yeah. This doesn't work. All right. So we are here and we use MCU bank and MCU pin. Huh? Oh. Okay. Right bit set. It's unfortunate. Wait, I can do it like that. Can use MCU bank. Remove that outside. MCU bank. Wait. Bit set high. Okay. Since yeah. Open drain or push pull. Floating. What we can do is we can ignore that and do it by hand like that. MCU bank. I found an error here. It's almost forgotten. What? What? By 8. Okay. I need to fix that. Four times 2. Need to fix that. Huh? Okay, here we go. That was wrong in the other one. Here. We would never have an answer. Hard error. Thankfully I found it. Okay, clone that trash. And that's B, not H. That's also wrong. Here. Remove that down there. CPP, this looks deep, yes. Vibe coding making a tool for Looney to draw data buses. Yes, please, foo! Help! Oh, damn it. Oh, no. What did I do? We have a low and high here. Fuck. This is messy. Okay, we invert that. Oh, what did I do? Ah! What is this? Ah! How do I... What is this? How do I quit this? Tell me the key code. What is happening? Oh no! Oh no! I zoomed in! I don't know if you can see that, but everything is enlarged. I used some... Oh no! How do I quit Windows Zoom? Windows and escape. Okay. Windows plus, yeah, Windows plus escape ends it as well. I wanted this, okay. That was odd. Pin. Okay, now we need to find the push-pull. I believe it's that. Reboot PC. I need to set the output first high before I trigger any MCUs. Okay, times 4. Oh, this is so... Output. Let me check the datasheet or reference manual. Huh? Add new bus. Huh? That's cool. Why is this window so... Bus color. What? You're a great vibe coder. Damn. Value signal 5. Okay. Is a GIF for you? Ah, it's amazing. A gift? You mean a gift? Or a GIF? Cool. Thank you. Thank you for that. That should help. That should help. Oh, a gift. With double F. Wait, let me find. Configure low and high. Okay, we are mode. Output mode, maximum speed is this. Output very fast. Output mode, general push-pull. native beta compression. Here we go. Push, pull, because there is no pull up, pull down. Okay, so this is the MCU bank. The issue that I see right now is that we don't have set command this will be, we need like an ID here. Or ID. Yeah, uint 8 t maybe a line. No, that's very hardware like reset command. Yeah, we'll do it like that. Set command, then host bus, set command ID. So the abstraction, and I need to fix it also here. It's the same, it's the copy. Set command. Oh. ID. And client bus will there is no broadcast yet, so, but, okay, that's fixed, unified, let's say. Okay, so this is CMD lines 16 CMD lines for MCUs. Then the next one that we need is the bus. Where is the bus? Here is the bus. Okay, so it's B, complete B. B is not initialized here yet. We have, what is C used for? We didn't use C, I believe. Yeah. We have only B, D, and A, and B. So what we will do is you will take the first 8 are alright. So basically we can use the config here, open drain, and that's B, config low register, and then the reset, and then we will do basically 1 and 7. Floating inputs. That's B. This is 0. Oh no, we need to pull it high. No, it's pulled high. I believe I will be floating here. Yeah. That's that. And B should be open drain as well. GAPI do BDB. Okay, here we go. We don't need that. And that should be all the lines. Enable receive, enable transmit. There's nothing there to do. Disable. That's just state ready. Set state ready. Or shouldn't do anything there. That's only for client. But let's keep that. State ready will be B. B and D4 low. This is that should be easy. B B set full. That's also B. Oh, the update here is quite easy. That's all B. Get full is B. Oops, what did I do? What is this B? Not 5. 5 plus 8, 13. I need to fix the comments there. Okay, set EOT, that's B. You know what? I do that. That's not D6. Comments are just bad. I want that trash. It's not PB12. Oh, it is. Well, Nice. Now it got the gist. Set type. Oh, this will be interesting. B. Boom. 10. No, wrong. Nope. Okay. Set high, and this is a B. Oh, 10. Oh, that's not out the R. That's actually GPI O B. Oh, it got it right. Interesting, yeah. that's actually interesting. Yeah, the vibe is strong, huh? Get data and oh yeah, by the way, this is wrong. Just need to concentrate on that. Okay, reset data. That just needs to be set high register. Too many. Okay. Oh, we are still command. Oh no. Wait. Set command. Yeah, this is now interesting. Because what is here? What is this vibe? No, this is MCU pin. It got it right, I believe. Yes. Now MCU ID and we have no broadcast yet. Set command is then basically see you bnack. clear register. Whenever we set something, I mean reset set clear, yeah. Clear register equals 1 shifted by this trash. To do broadcast, if there is one. Reset commands is basically same. I need that, damn it. So and I need to fix that in bus. Reset command, and I believe if we broadcast, I will extend this later when we do broadcast stuff. I need to fix that in that code. So and I need to fix that here. That's the individual command line. Okay, we are here. Host bus, reset command, command ID, reset command ID, just for performance measures. And that's all here. And the implementation, reset get clock, reset clock. PD1, this is PB. Oh, this is wrong. This needs to be that. Ah, interesting. I need to fix that clock. Get clock, okay. Huh? Oh no. What did I do? Get clock. Huh? Why was it only there? B. And we need 8 zeros here. Okay, then we need to fix it here. It's not that bad to review the code once to find maybe issues. No. Huh? Get clock is correct here. It's D0. I don't know why it was D1 for some reason. Okay, what is it? Seventeen. What? Where is it? House abstract class. Set. Oh, they deleted? Okay. I believe that should be it. And we don't mess with the bus anymore. Let me check what it builds. Oh, yeah, I need to remove everything else there. Like, yeah, fingers crossed. I mean GPIO, bus pin, bus bank, MCU, button pin. I don't need that anymore. I need GPIO. Button pin. We only need like button bank and button GPIO A. So this is A. Button MCU pins, that's covered. Bus pins are covered. C. I don't believe that this ever will work, so button, okay, yeah, whatever. Huh? What is this odd function? Just delete everything that's not used. Main CPP, we need to what is the MCU? File Raymarshall system fix debug. Include host bus blah. Okay, serializer. Okay, that's the serial stuff. Old programmer. Send bus packet. Yeah, that's not there anymore. Also, that is not used anymore. Send blink. Okay, that doesn't work. Ah. Set bus index. that's not used, that's not used. Bus LED, okay, send blink. And bus ping MCUs. Is there even, did I delete it? Oh, ping MCUs was probably, yeah, let me remove that. Ping MCUs and then write, oh no, I might have deleted this MCU state. Oh no, wait, here, ping MCUs. MCU state, yeah, that's, yeah, I'll leave it there. Send bus packet. Let me remove that. I will just start with a basic blink. Oh. This is all, I don't know. Can do that and send it. All right. Send bus packet is basically bus LED. That's it. That's data. So let's do it. Bus send packet. Oh, nice. Let's do one here. Send packet. Okay, does that compile? Oops. Huh? Oh, I have it twice. Okay. For whatever reason. Vibe coded. Control reaches not. What did I miss here? While get ready, if get for. Oh. Return true. What is this? Reset. Non-void. Okay. Still one problem left. Unused variable, okay. That's all right. Okay. Now I need to check the main here and see if we interpret anything here. Set index, blink. Okay, that should work. Crazy stuff. I will try to upload the code and test the first blink. Another boring coding session, but this is how my day looks like. Oh, by the way, here, the Perovsky thing is still glowing. All right, let me upload the client first. Oh, there is an error. Bus 8. Oh, wait. Do I still have the host? Yeah, host doesn't belong here. Okay. Sorry. I had some deprecated code. Okay, is it uploading? Alright, that one uploaded. And now if that works, I eat my shoe. It won't work, I tell you that. Never works. I know I need to find the control window. Okay, here is the control window. No. Here we go. Nope. Doesn't work. Getting some pepper and salt. Salt. Yeah. Phew. Do I get timeout? Why is this? Oh yeah, I'm sending toggle tx. Oh nice. Phew, thank you. Thank you for that. Oh. How do we test this even? We need to debug anything. Like, I don't even know where to start. Maybe we can debug. Oh, not in here. Oh, there is no debug in here, is it? Is there a debug? No. We don't have debugging in that window. That's not Moon River. Okay. I will do the following. That's the client. Let me do this. Send blink. I need to send packet. Let's do that. If we see if it was successful. Ser one, otherwise, so we can basically see if we get a response even from that. Let me upload the code. Nope. Timeout probably. Or what is the error? GDB, how do I use GDB? I know how to do it in Moonriver, but not how it works in here. Run and debug. Start debugging. Oh, okay. Can I do that? Yes, all right. Okay, we have the we can connect. Didn't break though. It didn't break. Yeah. Breakpoint doesn't work. Wait, can I pause? Okay. Nope. Failed. Nah, can't debug it. Is there a break command for debug break? Here, so I could somehow. Heh. No, I don't need a rewrite. Mm. Hmm. Okay, I'm lost. If nobody has experienced here, can't do anything about that. Okay, I will try to get a code from send packet, or unfortunately I can't do this. I can do the following though. We'll do okay. Okay, let's try again. Your bus won't work. Wait, that's the wrong one. Host bus here. Blah blah blah. Here, connect. 0. What? Oh yeah, I'm not returning the error. Don't care about that. Still 0? What? Why is it returning false then? Huh? Error code. Oh, wait. We don't receive the data. I need to flush it. Damn. Serve flush. Here we go. I don't receive anything. Toggle LED 0. Okay, here we go. Don't receive anything. Huh? Oh wait, is it filtered? Okay, I just sent this. Wait, not. This is max MCUs. Where is it? Response buffer, read loop, process. Count +1 header byte. Oh, wait. First is the length or what? Max MCUs. Oh. Gotcha. Okay, so we need to write once and then the message. Now I got it. Wait, here we go. The response has always the length of the data block. Alright. Still nothing. What happens when I send ping? works. Damn it. I cheat now. All DIY. Why do I get 0 here? Okay, I debug in a different way. Let me put debug in here. So basically we have utils first, and then we will do, or you know what, bus loop will be here. LED, and then bus get comments, oh, get comment isn't there. Okay, so let's do IOA. That's, yeah. Or we can also shift by 1, no, shift 2. And 1. GPIO, okay. So this will always reflect the state of the LED of our clock. I should also disable, leave the debugger on, because we don't need that anymore. And also unlock D7. We don't need that either. We could now debug even, I believe. Oh wait, it should always be high. Ah. Bus in it. Oh no. Okay, there is bus in it, but there isn't bus in it. Ah. All right. And when you don't initialize the bus, nothing happens. Yeah, it's not lit, so nothing happens. Why isn't it not glowing? Can try to debug that. That works. It's so funny. You can actually see how the pull down and the pull up on the. Oh wait. Ah. B. Let's check B. And we had GPIOD. Wait. As all the D's are off. So, config high, config low. Didn't we have B's? No, it was D. Wait. Yeah, here. But still, GPIOD. Doesn't look like it's configured correctly. GPIOA happened. There's something was going on there. Like except for 15 and what's this? 8, 9, 10, 11. GPIO 11 isn't here. Okay. Out. Oh wait, we also need to drive them. We never driven them high. Oh, we did here. But the why is GPIOD completely... Oh wait. It wasn't updated or something. Okay. Whatever. Next one. B. Okay, let's check B. Yeah. There will be 4. Yeah, not this is floating. Open drain. It's not updated yet. Oh, that's also an error. We need a high here. B needs to be high. That's a serious error. Okay. Let me update this, but this won't work. And I will also check if The LEDs are even blinking once. Oh, it's not even booting. Interesting. So this one isn't booting. Maybe I should make the reset disabled again. Okay. They should blink twice when they're booting. Let me reboot. Yeah. Ah. Let me check something. I don't know why it would be. Okay, there's the blink. Ah, here we go. Okay, okay. This is what I expected before. So actually, disable. Yeah, but this is not. This is not what I wanted. I wanted a blink. Don't even know if I get a response. Okay. I removed that again. Because I want to see a blink, not a constant light. We might need to go step by step, but It feels like it will be a long debug session. What I can do is make it simpler this way. Yeah. Handle clock low here. Client bus. Oh. Do I ever set the ID? Okay, we tested for 0, so bus ID, oh, here it is. Okay, so client bus. Handle request. That feels like that needs handle request here. Request receive. What do I set? Request type. Host. Oh. Wrong type. Okay. Next try. Yeah. I don't believe this will work. Nope. Of course nothing. Does it reset though? I need to see the LEDs blink. Okay, yeah. They're there. What I also need, you know what I will do? I will do a debug. That will be in here. Bus. Avoid debug. And then yes, I can do that. Wait, how do I share? Live share. How do I do it? Oh. Has the live share? session details. Oh, share read only. There it is. Foo! What? One up. Thank you very much. How do I copy the link? Copy collaboration link. Here we go. Here you can live. If you find errors, tell me. I will put okay. I will implement that, and then I will do the following. The hardware implementation here. I will do blink now, blink for and oh, I will just blink, and I need to define it utils. Oh wait, this is host. Oh damn it. Wrong code. What am I sharing, by the way? Am I sharing the host or the client? Oh damn it. It's the wrong. You also might need the host stuff. I mean the client stuff. Oh no. Did it upload to that? Oh no, wait, this is client bus. Which one are you reading? You're not reading this one. Here is the other code. So there is another session. That's client. Okay, I need host. Client bus. All right. Okay, client bus. I need bus though. I need the blink whenever debug here, the ID, I ignore that, and I will do a debug, or let's say I do it here, request type, I don't care. Okay, I remove the ID. We'll do a few things. State idle and debug once. I just need to see if it does this stuff correctly. Okay, it booted at least. It booted again. Oh, what happens? Uh-oh. I think I might have. Let me remove that quickly. Okay. Unbricked it. Unbreak my heart. No. I think the issue was that I programmed it with the wrong firmware. I don't know how that could happen even, because that usually isn't possible. Okay, so it's not even triggered. You was holding your breath. Okay, so this doesn't work, and I don't know why. It doesn't trigger at all. Where's the ID? Here, set data ID. For what? No. We do this. Okay, set cmd reset. I just want all the lines to be set now. Okay. Doesn't do anything. What? Huh? What was that? What's going on? And why is it getting hot? Yeah. Something's odd. Okay, that was the double blink. Let me check if it's high or low. They should all be high. Yeah. Yeah, all high. Set command. Yeah, I believe so. We don't get let me switch to that part here, client. This is getting hot. It's getting warm though. It looks like we might be doing something wrong. init.io, yeah. So let me check that. Okay, main. So yes, my eye is broken. Maybe I can show you. It's not that bad anymore, but I poked my eye with a stick. It's gross. Here. some body horror for you. Doing gardening stuff is Do you see that? Yuck. Yeah, I hope so. At least the doc said it will be alright. I got some meds. It's getting better now. While it was getting worse. It didn't leak. I didn't poke all the layers. Yeah. Oh, I have the storyboard. Yes, I can show you. Here. No brains. Okay, so I was doing some gardening with the lawnmower, and there was like some stuff laying around, and I couldn't mow over like the sticks that were here, and I went there to pick up that stuff that's on the floor, and this was the situation. I wanted to pick that up and bend over, and then this happened. I can re-show you the way it happened was like this. This is my eye. This is a stick. Yeah, now I can laugh. On Monday it was so bad I thought I might lose my eye. Yeah. It was only internal bleeding though. And now it's oozing, like there is like a scratch on the white thing, and it's oozing from that. And every time I wake up my eye is glued shut. And it really hurts when I touch now. Yeah. Everything when I move it and so on really hurts. But it will be alright. Yeah, I can now. But it wasn't easy. The first days, because I just recovered from a bad flu, and it was like not a severe, it was a really severe case of man flu. I was sick for 2 weeks, and then the first day I went out doing some gardening because it was overdue after I was sick. I just poked my eye. And now this thing isn't working, and it's already 12 o'clock. I think I will try to debug offline. I'm sorry, guys, and I will stream on Friday again. Yeah, I also Sion, I heard you had some shipping issues. I hope that gets resolved. Like, shipping batteries is terrible. I hope that the customs doesn't give you a hard time. Yeah. All right, peeps. I'm so sorry. I will check in the intermediate state. You can maybe find obvious things. Here we go. Commit. Oh yeah, there's a lot of things going on. Thanks. So message, new bus, not working yet. Yeah, alright, I will close the sessions anyways. here we go. I synced the changes, and if anyone is curious to take a look, it should be online. And I close the session now. Boop. Wait, where is it? Boop. All right. Oh, Sonic, you're still awake. Thank you, peeps, for listening in. Probably everyone fell asleep because it was only coding. I will try to debug it step by step and find all the bugs, and on Friday I hope we can either do that. That's the best part. Thank you also for the timing diagram editor. Yeah, peeps, look at that. Who did this for us? So we have CMD. We have also we have full. Alexa, fix it. Full, and then we can do BAM, and then oh yeah, we have clock, CLK. And then we have some that look at that, and then at some point it's like that, and we have EOT, and that's happening here, and this is how the boss looks like. Thanks, Fu. Thanks, everyone. I see you on Friday. So yeah. There's nothing to do. Tomorrow is sports, so I can't do streaming. But on Friday, I see you there. Bye bye, everyone.